Hello everybody. Now today we will cover the logarithm. Complete chapter we will do. Definition is if a is a positive real number, a is any positive real number other than 1 except 1 and x is rational numbers such that a raised to power x is equal to n, capital N, then we say that logarithm of n to base a is x. Means this is written as like log n base a is equal to x. How we are going to write? This is your e raised to power x is equal to n. This is your exponential form. This is your known as a exponential form. And how can you write down the exponential form into a logarithm form? How can you write down this in the logarithm form only? See now, this is your base and this is your exponent. So if you want to write the exponential form in the logarithm, what we will do? We will write the log, this a, which is the base, will come here, and this is the product of this one, a raised to power x. That will be here and is equal to this exponent. Means, for instance, suppose 2 raised to power 3 is equal to 8. This is your exponential form. You want to write in the logarithm form is there. Log, this is your base, 2 will be here, this 8 will be here, is equal to this exponent is 3. So any exponential form can be written as in the logarithm form, and if the logarithm form is given, that can be written in the exponential form is there only. Suppose you want to write this one, what we will write? You want to write this logarithm in the exponential form, then this base लीजिए and make the exponent of this one is equal to this number 8. So any exponential form can be written in the logarithm form, and the logarithm form can be written in the exponential form is there only. See, simply sometimes the question can be asked, evaluate, like log 81 base 9, this one. We want to know the value of this one is there, so that you can assume, let us suppose this is x. You can assume, let us suppose this is x, this is your logarithm form. Then this logarithm form can be written as in the exponential form base, and this will be the exponent of this base is there. So 9 raised to power x will be equal to this number 81. इसको हम लिख सकते हैं 9 raised to power x is equal to, this is 9 raised to power 2. You can compare the exponents, so you will get x equal to 2. It means the value of the log 81 at the base 9 is equal to 2 is there. So any exponential form can be written as logarithm, and logarithm form can be written as in exponential form. Have a look. Okay, now there is a question, log y base 3 is equal to x and log z base 2 is equal to x. Then you have to find the value of 72 raised to power x in terms of y and z. So look at here now. Here we are given log base 3 y is equal to x. So this can be written as, this is your logarithm form, you can write on the exponential form. It means what? 3 raised to power this x, base का exponent ही आएगा x, and that is equal to this y, 1. Similarly, this one can be written as log base 2z is equal to x. In the exponential form, the 2 raised to power x is equal to this z. This is 2 is there only. So we know the value of 3 raised to power x in terms of y and 2 raised to power x in terms of z. Now you can expand this one. So this is 72 whole raised to power x. This is, you are supposed to do the factor of this 72. Just write down in the terms of 2 and 3. So this is 3, 6, 2, 18, 2, 9 and 3 is here. So this can be written as 2 raised to power 3 into 3 raised to power 2 is equal to whole raised to power x is there only. This is, you can write down. Now you can break this one because we know the value of this and we know the value of this one. So you must write down, इनको में क्या करना है, in terms of 3 raised to power x or 2 raised to power x you are supposed to write down. So this can be written as 2 raised to power 3 whole over x into, you can break it, 3 raised to power 2 x. This can be written as again, this is 2 raised to power 3x into 3 raised to power 2x. Again you can write down in the form of this and this one only. So this is can be written as 2 raised to power 3, 2 raised to power x whole raised to power 3 into this is 3 raised to power x whole raised to power 2. But 2 raised to power x is equal to what? Z. So you can write down zq into 3 raised to power x is equal to y. So that is y square. So the value of this 72 whole raised to power x in terms of y and z will be equal to, you can write down y square zq, and this is your answer. Have a look. Now the fundamental law of logarithm is there. The first log is there. If mn are positive real numbers, then log m into n means at any base is always equal to log m plus log n. Means if the product of the two numbers at any base is equal to the sum of the logs is there. For instance, suppose log 2 into 3 is given at any base. Suppose 10. So this is equal to log 2 base 10 plus log 3 base 10. That will be equal to the sum is there only. And one more point is here only. Then in case of the m into n, there may be the more than positive real numbers. M और n की जगह more than हो सकते हैं. For instance, suppose log m and p is there at any base a, then you can write down log m base a plus log n base a plus log p base a. You can break it. This one is there only. Second law is there. If log m over n, m and n are the positive real number. Remember, base a is there, so that can be written as log m minus log m. Means, for instance, suppose it is given like log 10 over 3 base a at any base number like 2 you can take. This is equal to log 10 base 2 minus log 3 base 2. You can write down this is there. Similarly, third law is there. Log m raised to power n at any base is equal to n will come first. N into log m is there. Fourth law is there. Log 1. The value of log 1 is always equal to 0. Log of 1 is to any base is 0. Because just see now, this is your logarithm form is there. If you are going to write in the exponential form, so how can you write down a raised to power 0? इसको अगर exponential form में लिखेंगे तो क्या होगा? ये बराबर क्या होगा? a raised to power 0, and that is equal to 1. Base का exponent is equal to this one, and this is already we know that कि किसी भी positive real number का exponent अगर 0 है, so that is always equal to 1. So the log 1 is equal to 0 by this one is there. Fifth is there. If the base and the number, whatever is here, same is here. अगर a is here, that is always equal to 1. Means the log of any positive quantity of the same base is always 1. This is, इसको अगर if you are going to write in the exponential form, this one कैसे लिखेंगे? a raised to power 1 is equal to this a. So it means if the base and this value is same, then always equal to 1. Sixth law is there. If m is a positive rational number and a and b are the positive real numbers, but condition is a and b is not equal to 0. So suppose log m base a is given है, तो you can write down this is by introducing the another base. दूसरा base introduce करके हम लिख सकते हैं log m base b over log a this over base b. Means suppose this is given, suppose log 5 base 2. So this can be written as, you can introduce the bases here log 5 at any base, suppose a over log 2 base a. You can introduce the another bases there, and this can be written as in the form, fraction form is there, rational expression form is there only. Now have a look. Rest of the laws also we will discuss. Okay, now the seventh law is there. If a is any positive real number and n is a positive rational number, then a raised to power log n base a. Means whatever the value is here, same should be the base, then that is equal to n. That is equal to n. Means you can say like for instance log 2 raised to power 5 base 2. So that will be equal to the 5 is here only. Means whatever the number is here, same should be here. Which should be the same, that is equal to this number. Similarly, eighth law is there. If a is a positive real number and n is a positive rational number, then log a raised to power q into n raised to power p is here. So that can be written as p over q into log n base a. Means for instance, suppose if it is given log 3 raised to power 2 3 raised to power 2, and here is 5 raised to power, suppose 4, or you can take the 7 is here, so that can be written as 7 over 2 log 5 base 3. This is, means this can be written as, this n and a will remain as it is, and this is p, the exponent will be written in the form of the fraction p over q, like, so that is 7 over 2 log 5 base 3 is here, that can be written. And ninth law is there, if log e raised to power n into m, that can be written as 1 over n log m base a, because this is already we discussed, in case of the log base a m raised to power n, that was equal to n log m at the base a. This is already we discussed, but now this base is given in the exponential form, then this is equal to 1 over n is equal to log m base a. Similarly, log x at base a can be written as 1 over, you can change this x, the base, and base, this number is here only, so this can be written as this one. Have a look. Yes, now few useful results is there only. First one is there, if a is greater than 1, then log x at the base a will be less than 0, which is going to satisfy, means this axis lies between 0 to 1. Then the value of log x at base a, when a should be greater than 1, then it will be less than the 0. Log x base a will be 0 if x is equal to 1, but the a should be greater than 1 is here. Similarly, log x at base a will be greater than 0 for all x is greater than 1. For all x is greater than 1, but a should be greater than 1 is here only. X is greater than y, then log x at base a will be greater than log y over a, because log x a is increasing function. But the condition is here, this a is greater than 1. A is greater than 1. But if a is going to become a less than 1, like here only, then this same condition, this one, x is greater than y, then it's become less than is here. Look at here. Now log x less than log y at the base a. If a is less than 1 is there. It means if it's greater than 0 but it's less than 1, then x is greater than y will be equal to log x less than log y. Here is x is greater than y, but when it is greater than, in case if a is greater than 1 is here only. So similarly, if a is greater than 0 but less than 1, then log x base a will be less than 0 for all x is greater than 1. Here is x is greater than 0 but less than 1. In that case, it is less than 0 is there only. But here is the x should be greater than 1. Similarly, log x at the base a will be equal to 0 if x equal to 1. Log x at the base a will be greater than 0 for all x satisfying this condition is there. So these are the few results are there only, which you must remember. Have a look. Okay, now the system of logarithms. There are the two system of the logarithm is there. First is the common and second is the natural logarithm is there. Common logarithm means if any log is given, suppose base is not given, then it means base will be the 10. In the common logarithm, base is always 10 is there only. We are supposed to take the 10 is there. If the base is not given, it means the base is 10. And this is also known as a brick system. This one. But in case of the natural logarithm, the base will be e. Base will be the e is there only. The e, the value of e is lies between 2 to 3, which is a rational number. This one. And e is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial. Likewise there only. This is the, from here only we are getting the value of e is there only. That's e is equal to, this is, 1 second please, yes, like, and the value of the e is lies between 2 to 3 is there, that is the irrational number is there only. So if it is the base is not given, it means base is 10. Natural in case of e is there. Now this question we are taking, prove that log 50 is equal to log 2 plus 2 log 5. You are supposed to prove, nothing is there. इसके साथ सिंपली फैक्टर करिए 50 के, तो that can be written as 2 into 2, 2 into 5 into 5 you can write down, just simply this is, and this can be written as log 2 into 5 raised to power 2. you are supposed to do the factor of this 50 only. 2 into 5 into 5, 25 into 5, 2 into 50, so that you can do the factor, then write on this one. Now isko just you can apply this one, log m into n, that is equal to log n plus log n. You can apply this first log. So this can be written as log 2 plus log 5 raised to power 2. This one. Simply you can do that. Simply you can break this one is there only. Look at here now. This one. And this is equal to log 2 plus. And here you can apply this one. Log m raised to power n is equal to n log m. This log you can apply here only. So this log 5 raised to power 2 can be written as 2 log 5, which you want to prove. Which you want to prove is here only. Now one more question is there. He is saying you are supposed to evaluate this one. So see now, this is log 6, keep as it is now, plus this can be written as by using this one. If n log m is there, that can be written as log m raised to power n. So this can be written as log 5 raised to power 2 plus log 4 as it is. You can keep in bracket this one. And from here you can take out the minuses common is there because both are negative. So minus sign you will take the common. It will become a log 3 plus log 2. Here you can apply now. Here you can apply log this one. Log m into n into p at any base a, that is always equal to log m plus log n plus log p at the base a. So here you can add on. Now this is given. So you can change in this form only. So this can be written as log 6 into 5 raised to power 2 into 4 minus. This is also can be written as 3 into 2. Now this is equal to what? Log 25 into 4, 100 means 600 minus this is your log 6. Now here again you can apply which one is there? This one. Log m over n is equal to log m minus log n. You can apply this formula. So here is, it can be written as log 600 over 6, that is equal to log 100 is here, and this can be written as log 10 raised to power 2, this one. So by using this property again you can write on this is equal to 2 log 10. And if the base is not given, then common is there. So it means his base is also here 10, and this is the value of this one. You know already one. ये हमने already discuss किया कि log a base a पर is always equal to 1 by using this one. So this is the answer of this one only. Have a look. Yes. Now one problem is there. You have to find the value of the log 168 at the base of 54. Information is given log 12 at the base 7 is A and log 24 at the base 12 is B is here only. You have to find out here. The important point is here. यहाँ पर base 54 है. Here is the base 7. Here is the base 12. So it's quite complicated. So because the base is totally different in all these three cases. So what we will do? This 168 can be written as 24 into 7. Now you can take the log of both the side at any one of the base. So at the 12 I am taking by keeping mind this one only. इसको ध्यान में रखते हुए तो log base 12 168 is equal to log 12 24 into 7. So here you can apply log m into n, that is equal to log m plus log n, that we are going to apply. So this log 168 by 12 can be written as log 24 plus log 7 at the base this one. See now, this is log 24 over 12, keep as it is, but this can be written as by using this one. Log a base b है, so that can be written as 1 over log b base a. By using this law is there only. So this can be written as 1 over 12 base 7. Why we are going to write? ऐसा हम क्यों कर रहे हैं? क्योंकि हमको इसकी वैल्यू पता है. तो anyhow you are supposed to break in this form, in this form. तो देखिए, this is your b, this is b, and this is your 1 over this is a is there. You are getting this one. So log 168 at the 12 is b plus 1 over a. Now you need, because here is the base is 54. So just take the log of 54 at the same base at 12 is here. So this can be written as log 54 at the base 2 over log 12 at the base of this 2. This is the law is there only. Log A base B is there, that can be written as log A at any one of the base, like P you can take, and log B at the base P. You can introduce the bases here only. So by keep in mind this one only. So इसको हमने लिख दिया log 54 over log 12 at the base 2. 54 will be break 3 raised to 3 into 2. So that can be written as log m into n. Again you can apply log m plus log n. Here is log m plus log n is here. Now this 3 log 2 and this is here the base, whatever the base is here, same value is here, so that is equal to 1. ये भी देखिए 2 इधर आएगा, 2 log 2 base 2, so 1, so 2 into 1 is 2 plus this one is there. So we are getting one of the relatives here, means log 54 over this one. Now just see, just keep your mind, just b is given here only, take it this b is given 24 over 12. So same method again we are going to do, that is this log 24 over base 2 over log 12 base 2 by using this one. And this 24 can be written as 2 raised to power 3 into 3, and this is 2 raised to power 2 into 3, that is 12 is there. So this is again you can break 3 log 2 base 2, so that is 1. So 3 into 1 is 1 plus this one. Similarly this it can be breaking here only. See now, this is equal to, this can be written, just now what we are going to do is here only. Now we are going to do the cross multiplication. हमने क्या किया, इससे इस b को multiply किया, and this is over 1 is here, 1 into this one. So you are getting 2b plus b into log 3 base 2. Here is 3 plus log 3 base 2 is here only. You can transpose. देखिए log 3 base 2, log 3 base 2 with b. You can transpose here only. So this is b minus 1. You can take this common. And 2b you can send this, right? So you will get the value of log 3 at base 2 is equal to this one. You are getting this is. Now you need the value of this log 54 at the base 12. So again, here only, then 3. This is the log 54 over 12. Then again you can break, this one is there only because b is log, इसका value कितना आ रहा हमारा, this one is there. ये values यहाँ से log 3 by 2, log 3 beta is 2. These values you have to put here because that is equal to this one, log 54 at the base 12. Log 54 at the base 12 भी है, तो इसकी जगह पर log 3 base 2, log 3 base 2 पर ये value रख दीजिए. This is you are supposed to put here and here only. You will put here and solve it. You will get log 54 at the base 12 is equal to this one. But we want to find out the value of this one. So log 68 over 54. So at the base 12 you can write on this one in this form only. By using this one, we know the value of this. We know the value of this one only. हमें इसकी value पता है. We know the value of this. Look at here. We know the value of log 168 at base 12 is this one. And log 54 at the base 12 is where it is, this is there only. These values you have to put here only and solve it. You will get this one. Here you have to take the LCM is there. So it's become AB plus 1 over A. Directly we have written, and this is here only. The log 54 over this one, you can put the values there. This one, so A plus B over A into this one you will get. And this is your answer. Have a look.